This is a lesson about defining linear functions. It corresponds to topic 8.1 in digits, and a lot of this is going to be review of topic 5, but more situational. So let's take a look at the first one. Match the situation with the graph that could represent it. For A, it says the length of your pencil lead while you don't use your pencil. B says the length of the line you draw when with your pencil over time. And C says the length of your pencil lead as you use it over time. So if we take a look at each one of those, we want to think about what happens to each one. So for A, the length of your pencil lead while you don't use it stays the same. The length of the line you draw with your pencil over time gets longer. And the length of your pencil lead as you use it over time gets shorter. So with those in mind, we want to match the graph with the situation. So the one that stays the same is the constant, so I'm going to put A here. The one that gets longer means it goes up, so the first one is B, and the one that gets shorter means it goes down or decreases, so that's C. Moving on, a linear function is a function whose graph is a straight line. We already knew that. A linear function rule is an equation that describes a linear function. So if you look at the graphs here, the first one is a linear function, and if you look at this down here, right here, this is the rule for it. Y equals x plus 4. The second one is not linear, but it is a function, and we have a rule right here, y equals the absolute value of x. And the third one is not a function, but it is linear. And here is the rule for that one. So there's only one linear function in these diagrams, and it is this one right here. This is a linear function, and we have the rule y equals x plus 4. Let's take a quick reminder of linear functions. Y equals mx plus b is an equation of a line. The slope is the m, and that's the number in front of x, or the coefficient in front of x. So that means that this graph, no matter where we start, goes up 1 over 1, up 1 over 1, up 1 over 1. So that's the slope, and then the y-intercept is 4, and you notice that's where it crosses the y-axis. So that's a quick review of material we've already done. So let's take a look at the next part of our notes. Under each of the following graphs, write the equation, the choices are on the right, that matches the graph. So again, I'm going back to this idea that y equals mx plus b. Any non-vertical line can be written in that form. So if you take a look at the first one, the y-intercept is 0. So we're going to have a plus 0 at the end. The slope, I go up 1 over 1, up 1 over 1, up 1 over 1. So the slope is 1. So we have y equals 1x plus 0. So that means I'm going to write this one, y equals x. For the middle one, we have a y-intercept of 0, so I'm going to have plus 0. And the slope, I go down 1 over 1 right, down 1, right 1, down 1, right 1. So it's down 1, right 1 is the slope. So here's my equation, and then we simplify it. So negative 1 over 1 is negative 1. That means that y equals negative x is our answer. If you take a look at the third one there, the y-intercept, again, is 0. And the slope is up 2 over 1. Up 2 over 1. So it's 2 over 1 x plus 0 equals y. So if you simplify that, we would choose y equals 2x. Alright, let's move on to the next page. Now you are asked to do this one. What is the function rule of the graph? So I'm going to start with my equation y equals mx plus b. My y-intercept is right there, so it's negative 3. And my slope, I'm going up 1 over 1, up 1 over 1, up 1 over 1. So it's 1 over 1. So my equation then, if I simplify it, 1 over 1 is 1, and I don't need a 1 in front of the x. So it's y equals x minus 3. Alright, this next part describes when functions, or what functions are linear and what are not linear according to the rules. So we have been talking so far today about y equals mx plus b. If you notice though, not all of these here look like that. But it doesn't matter because they all can be put into that form. They might not have an x and a y, but they have two variables. So it doesn't matter what the variables are. If you take a look at the non-linear part, the non-linear parts have different things that you can't have for linear. So right here, you have absolute values. So that makes it non-linear. The second one, we have an exponent of 2 with the variable. We cannot have that for it to be linear. And the third one here, we have a variable in the denominator. So that makes it non-linear. So what we need to do right now is we need to write those things down in our notes. So I'm going to put up what you need to write down, and you need to pause the video. Okay, so please write down those 3 sentences. If it's linear, it can be written in the form y equals mx plus b. The variables can't have exponents, and the variables cannot be in the denominator. Once you have those written down, unpause the video and continue on. Alright, now we are asked to determine if each one is linear or nonlinear and explain the reasoning. So the first one, if we look at the rules that we just wrote down, it breaks the rule. It says variables can't have exponents, but right here, the variable x has an exponent of 2. So this is non-linear. And the reason is variables can't have exponents. Alright, the second one, y equals 4x. If I add on a 0, that's the same thing. So that's in y equals mx plus b form, so this one is linear. The next one is the same thing. I could add a 0 there. So it's y equals mx plus b, so this is linear. This next one, y equals 8 over x. The third thing I wrote down up above is the variables cannot be in the denominator. So this one, because the variable is in the denominator, is non-linear. Alright, and then the last one, y equals x minus 2, that is in the form of y equals mx plus b, so this is linear. Okay, if we go back up here for a minute, we can see here that this one here can be written as b equals negative a plus 7. Plus 7. So that's in slope-intercept form, y equals mx plus b. The next one is y equals mx plus b. The third one is y equals mx plus b. And then the fourth one, though, many students might get confused here. So I'm going to write it as z equals, and then something divided by 2 is the same as taking half of it. So it's 1/2 y. And if you write it like that, it's easier to see that it's y equals mx plus b, and the plus b would be 0. Again, the variables don't matter. Alright, let's go ahead and move on to the third page of our notes. And this one says the points -1, -1, 0, 0, and 1, 1 are on the graph of y equals x cubed. Your friend says since you can draw a straight line through the 3 points, y equals x cubed is a linear function. Do you agree? Why or why not? So first of all, you're going to look at our notes and notice that we cannot have an exponent with our variable. So I disagree. Variables can't have exponents. In linear equations. So let's take a moment to see what's going on here. So if I make my axes, and I plot the points -1, -1, 0, 0, and 1, 1, I can see that those do look like they form a line. Now, if I have x equaling 2, y equals 2 cubed, I get 8 out. So that means the point 2, 8 is also on my graph. So the point 2, 8 is a little off my grid. It would be right there, 2, 8, and you can see that that does not form a line. What's going to happen is it's going to come up like this, and then it's going to curve in here, and then come up back up here. So what you need to understand is that when you put another point on there, it doesn't line up, and that's why it's not a linear function. Alright, let's take a look at the dog walker situation. It says a dog walker earns $10 plus $3 per dog. So if you have 3 dogs, you put 3 dogs into the function, you get $19 out. This is a function that describes the situation. So let's talk about writing a function for the next one. A swimmer burns 8.8 calories per minute while swimming laps. So what you want to identify is that the calories per minute is the rate, and we have already learned that the rate is equal to the slope. So that means that 8.8 is our slope. So the function rule to describe this is we're going to use different variables to represent the different things. So the calories burned, C, is equal to 8.8, that's the rate, times the number of minutes that I swim, so M. So C equals calories burned, and M equals minutes. So c equals 8.8m is the linear function rule for that situation. The last one, Matt is 3.5 years older than Sam. Write a function rule that describes Matt's age in terms of Sam's. So let's use m for Matt's age and s for Sam's age. And it says that Matt is 3.5 years older than Sam, so Matt is means equals 3.5 years older than Sam, so I'm going to take Sam's age and I'm going to add 3.5 years. So that is the function rule for the situation. Now in your notes, write down number 1's answer. And then for number 2, when it says circle each linear function rule, I want you to write down which ones are linear. So if you think y equals 4x squared is linear, write that down. If you don't think it's linear, don't write it down. So put number 2 on your paper. Then for number 3, you earn an allowance of $5 each week. You earn additional money M for helping others in the neighborhood. Write a function rule to find the total income you can earn in 1 week. Write the equation down that matches that. And then I want you to skip number 4 and do number 5. Reasoning. Is the graph of his distance over time linear? And explain. So once you have those written down on your note paper, you're going to now go to Google Forms and put those answers into the Google Doc. Actually, for number 2, let's go back there, and I'm going to say that one's A, B, C, and D. So what you're going to do is tell me if A, B, C, or D are linear functions on the Google form. And the Google form is bit.ly/adesso8-1. Again, that's bit.ly/adesso8-1. And that's where you're going to put the answers to these questions.